You know how we've learned different techniques for taking derivatives? There's the quotient rule, there's the product rule, there's the chain rule. There's all these different kinds of techniques and processes. One of the ways that you can take a derivative is what's called logarithmic differentiation. And that's just a really long couple of words for let's use logarithms to try to see if we can make the problem hopefully solve a different way. It would be nice if it was easier, but another technique. So, like out in the wherever you have your tools, whether it's in the garage or somewhere in the house, you have different tools for different processes. You have hammers and screwdrivers and things, and they're for different techniques. And so this is another technique. Now, what's frustrating about this technique is it doesn't really seem like it's helpful. And I think it does look indeed like it's not helpful. But you remember how in college algebra, you learned all these techniques that didn't seem very helpful right then. And you were like, and I'm learning these. Why? They don't seem to do anything, like simplifying complex fractions, rationalizing denominators. And then you get to Calc 1 and you go, oh, that's why I learned how to rationalize a denominator or a numerator, how to simplify complex fractions. And so you went, okay, now here I can see it being useful. Didn't seem to be too useful in college algebra. So we're going to learn this technique, and you may be going, I don't see how this is very useful. And there'll be later times where it might come in really handy. Not in this class necessarily, but okay, but it's a technique, all right, for which you may be responsible and which you may be tested on. So we need to learn how to do this. It's good for you. All right. Now, if you've forgotten how logarithms work as far as writing them as a single log and then writing them as the sum and difference of logs, there's a support video that goes with this, and the link to it is down in the description where all the other links are, to the next videos, previous videos, and to homework, all right, or practice problems. I shouldn't call it homework. All right, now let's try one, all right, and we have y is equal to the square root of x plus 1 over 3x minus 4. Now, if I was not going to use logarithms, I could think of this as y is equal to x plus 1 over 3x minus 4 to the 1/2. I could use the chain rule, so it's the chain rule with the quotient rule in the middle of it. You've done worse. Okay, so when we get through with this problem, the way we're going to do it, go back to here and grab a piece of paper and try the chain rule with the quotient rule in it and see if you get the same answer. You should get the same answer. All right. Now, we're going to use the technique where we're going to split this up, but what I want to do is to say, okay, if it's all under a square root, then the numerator is raised to the 1/2 power, and the denominator is also raised to the 1/2 power. All right. Now, what we're going to do now is we're going to take the logarithm of both sides. You can use any base you want to. You could use log base 4, log base 2. The tradition is just to take the natural log of both sides because you only have to write 2 letters, ln, as opposed to log and then a base. Okay, so let's just take the natural log of both sides. You just have to sort of, like I keep saying, find your humor where you can. So just like we can square both sides or multiply both sides by 2 or square root both sides, we are going to take the logarithm of both sides. All right. Now we're going to use some of the properties of logarithms to split this up into the sum and difference of logarithms. So the natural log of y is just by itself. But remember, if you have the log of a quotient, right, then it's in this case a natural log of the top minus the natural log of the bottom. And if you need a review over how this is, don't forget to look at the link in the description to this support video where I'm going to remind you about how this works, right? So to split this natural log up, you're going to subtract. And then also what you need to remember is that this power right here pulls down in front, like that. Okay, so you have the natural log of y is 1/2 the natural log of x plus 1 minus 1/2 the natural log of 3x minus 4. Okay, now, so now we've got it split down into where it's individual sums and difference of logs, all right? And what we're going to do now is to take the derivative on both sides with respect to x, and this makes it implicit, okay? So we're going to take the derivative with respect to x on this side and on this side. Again, whatever you do to one side, you have to do to the other side. So we're going to take the derivative of both sides with respect to x. Now, on the right-hand side, everybody is an x, so that's kind of nice. On the left-hand side, it's a y, so that's the implicit part. And here we go. Now, what's the derivative of the natural log of something? It's 1 over that something, and then you loop back in and take the derivative of the inside of it. It's not just an x. So remember, the derivative with respect to x of the natural log of x, or you could say u, is 1 over u du dx. Right, loop back in. All right, so what we're going to do is to do that. You're maybe already getting busy on it since I wandered over here. So you'd say the derivative of the natural log of y is 1 over y. Loop back in and take the derivative of the inside, so that's your implicit reminder from implicit differentiation, equals, you have your 1/2. The derivative of the natural log of x plus 1 is 1 over x plus 1 times the derivative of x plus 1, which is 1. You would normally write that down, but I want you to remember to do it, minus 1/2. The natural log of 3x minus 4, its derivative is 1 over 3x minus 4. Loop back in and take the derivative of the inside. Okay, you okay? All right. Now I wouldn't say this is making me feel really too good. This is 1 over 2 times x plus 1 minus 3 over 2 times 3x minus 4. Whatever we can do to make it look a little better kind of makes your brain feel not quite so weirded out. All right. Now, so I'm kind of to this point, but what my assignment was to try to find the derivative, which is this part. And remember how when we had the section on implicit, we tried to get all our dy dx terms together and then divide out by whatever was there that we didn't want? Kind of vaguely remember that. Well, in this case, I've already got it technically divided by y, right? Because it's 1 over y. So what I'm going to do is to multiply both sides by y, because remember, dividing by a fraction is the same thing as multiplying by the reciprocal. So we're going to multiply this side by y and all of this side by y. And you're like, okay, what was y? So y up here is that square root of x plus 1 over 3x minus 4, or you could think of it as x plus 1 to the 1/2 over 3x minus 4 to the 1/2. So I'm going to use this version because it just sort of seems to fit more, okay, with what's going on with separating out the 3x minus 4s and so forth. So what you're going to have is 1 over 2 x plus 1 minus 3 over 2 3x minus 4. And this y is going to cancel this y. And what you'll have over here is x plus 1 to the 1/2 over 3x minus 4 to the 1/2. Okay, Now, um, I'm not sure that this is making me feel just really too good. Um, but we could clean it up. Maybe it'll get better. Okay, so let's keep going because this is definitely not going to get you full credit on the assignment if you stop here. So I could try to find a common denominator here, which would, they both have a 2. The rest of them need an x plus 1, 3x minus 4. So you would multiply this first fraction by 3x minus 4 over 3x minus 4. And you would multiply this second fraction by x plus 1 over x plus 1. And that would give you your common denominator. And just drag along all your little bits and pieces. All right. So here we go. So I forgot my 3. So this 3, I lost my 3. There we go. All right. Speaking of bits and pieces. Okay, so 3x minus 3x is gone. And minus 4 minus 3 is minus 7 over this. Yeah, let's put it right here. X plus 1 to the 1/2 over 2, x plus 1, 3x minus 4, 3x minus 4 to the 1/2. So I'm kind of multiplying all my parts together. Now, do you see this right here? Okay, they would reduce, and you would have minus 7 over 2, and this would be x plus 1 to the 1/2. And this 3x minus 4, 3x minus 4 to the 1/2 is actually 3x minus 4, 1 plus 1/2 is 3/2, right? This is what it looks like combined. But think, if you write this down as a radical, it's going to be the square root of 3x minus 4 cubed, and that would be 3x minus 4 times the square root of 3x minus 4 that's left over, which is what we already have. Okay, so it's not going to clean up and make something small if you can't have exponents with fractions underneath there. And remember, it started off with square roots way back up in here. It started off with square roots. So trying to get it back to that form, I'm going to leave this the way it is. And then I'm going to change my half powers back to square roots. So you would have 2 square root of x plus 1. Let's put the 3x minus 4 in the middle, so that all my non-square root stuff is in the front. So you'd have the square root of x plus 1, square root of 3x minus 4. And this is my dy dx. And I don't know about you, but that doesn't seem to be, look how many steps this took. I can't even get them all on one page. There we go. All right, that's quite a lot of steps. I'm not sure that the power rule, the tackling it this way. In fact, I did it that way, and it took me 1, 2, 3, 4 lines, okay, to get from that point to the answer. I'm not sure this is faster, but in the future, this may be the only thing that's going to work for you. So this is a skill that right now you may be kind of frustrated with, but it could come in handy. So let's keep trying. Keep going on down the road. Let's try another one. Y is equal to the sine of x to the x power. Okay. Now, this one is kind of weird looking, so let's try the natural log. I know I shouldn't talk like that, but let's be honest, math is kind of weird looking once in a while. Okay, it's also really cool and does a lot of neat things. And I guess because all my training was engineering, I'm kind of irreverent about math. So if that's offensive to you, I'm sorry. There's probably other people that might be a little bit more reverent, but I do tend to be kind of, I don't know. I make fun of math maybe more than I should. But it makes me smile. It makes my students smile. All right. So I take the natural log of both sides, and I'm going to take the power and bring it down. So I would have the natural log of y is x, natural log of sine x. And now that I don't have so many parentheses, I'm going to put my x right there. All right. Now I'm going to take the derivative with respect to x on both sides. So taking the derivative with respect to x on both sides. Okay, like this. Okay, sort of. There we go. The derivative of the natural log of y with respect to x is 1 over y dy dx. And this part inside this derivative that we're going to take is a product. So it's the first times the derivative of the second. And the derivative of the natural log of sine of x is 1 over sine x. Loop back in and take the derivative, which is cosine of x, plus the second times the derivative of the first, which is 1. So see, you just learn these rules and just keep talking to yourself. Use the same steps, the same voice that you used back on learning those rules, and just keep applying them where they seem to be appropriate. And so not too much gets added into that. So what you would have here is x, right? And you would have your I'm sorry, I just drew a blank for a second. This is terrible. All right, so I guess we could call this cotangent of x, but because of something that's going to happen later, we're going to not do that. So for a minute there, I just sort of went, why didn't I cancel that out? I do try to work these out before I do them for you. But every once in a while, I'm thinking, why did I do that? And then I remember. All right, so this is about as clean as I can get this right-hand side. So now it's time to try to solve for dy dx. So I'm going to multiply both sides by y. And this y is going to cancel this y. And that's going to leave me x cosine x over sine of x plus the natural log of the sine of x times what y was, and y was sine of x raised to the x. So it's sine of x raised to the x. All right. Now, this is the distributive property. So I can take this times here and this times the second location, right? All right, so here we get ready for some really cool kind of math. Let's talk about exponents. So we have x cosine of x. Okay, and this sine of x right here is going to cancel out one of the ones from here, right? So if this had been sine x cubed, if this had been a cube, it would reduce by 1 and become a 2, right? Because it cancel out one of them. If this had been a 5, we would cancel out 1 and we would get 4, right? Well, so it's an x. So we would have sine of x, and whatever x is, we're going to reduce it by 1, right? If it had been a 5, it's now a 4. If it was a 3, it's now a 2. That's kind of weird looking. We haven't done anything like that. Plus, right? And we've got the natural log of sine of x times sine of x to the x. And these two signs don't see each other because the one on the left is inside of a natural logarithm, so they can't do anything cool. Okay, so here we go. What do you think we should do? Well, I don't think there really is anything that we could do. This doesn't look like it's getting anywhere, right? Um, we could change well, I don't think that we can change anything here and get anywhere near better. What do you think? Because sometimes when you try something in math, you think, I don't think it's getting better. I think it's getting worse. What do you think? Is this better than where I just was? I'm not seeing it that it's better with this x minus 1 and this x and this all split up. It doesn't seem like it's getting any better for me. So what do you think? Should we just not do that and go back up here and say that's my answer? Because sometimes when you're working a problem, solving a situation, designing something, trying to come up with a new manufacturing process, whatever you're doing, you think, let's try this. And then you go, no, I don't think that helped. And sometimes you have to back up. So I'm not thinking that helped. So let's back up. And I'm going to go to the line that's above it. But I'm going to stick this out in front so it's not so bad. And I'm going to go ahead and convert this to cotangent and leave this as the natural log of sine of x. And I'm going to say I think this is about as good as I can get it, because I do think that this, after you change the other thing to cotangent, is better. Okay, so this is better. But sometimes I think as teachers, we don't show you that it's okay to try something and go, no, and back up. All right, so here we go. One more. All right, so what if you have y is equal to x? 1 minus x squared over 1 plus x squared to the 1/2 power. It's supposed to be a half. All right. Now, this one I can see, maybe I don't want to do the product rule, quotient rule, power rule, and everything all together at one time, but I think you've probably worked one like this, probably in class. But we're on the logarithmic differentiation technique. So we're going to take the natural log of both sides. And then we're going to use our logarithm properties to split the right side up. So we have the natural log of y, and we're going to write this as the sum and difference of logarithms. So remember that if you have a product, you separate them into individual logarithms by a sum, and if you have a quotient, you separate it by making it a difference. So you had sum and differences. If you've forgotten, there's a little tiny short reminder video that the link is in the description. So it's the natural log of x plus the natural log of 1 minus x squared minus the natural log of 1 plus x squared to the 1/2. Okay, then we pull the powers down in front. Okay. Now I have not yet taken the derivative, right? It sometimes makes your brain think you've taken the derivative because you pulled the power down in front. And so pulling the power down in front makes your brain go, okay, I've done that step, but you didn't take one off the power. Okay, so you're not actually taking the derivative. So here we go. Now I've got it simplified to the sum and difference of logarithms. I'm going to take the derivative with respect to x on each side. So this is going to be 1 over y dy dx. And the derivative of the natural log of x is 1 over x. And the derivative, if you loop back in, you're going to have 1 plus 2. This is 1 over 1 minus x squared. And when you loop back in, you have minus 2x. Minus a half, 1 over 1 plus x squared. Loop back in, and you have 2x. Okay? Alrighty, let's see where we've got 1 over y, dy dx. Okay, so this is 1 over x. Now, this 2 times this minus 2x here, all right, is minus 4x over 1 minus x squared. All right? Minus this 1 half and this 2 that's over here. They cancel, right? Leaving you an x, and you have x over 1 plus x squared. All right? Now, so far so good? Now, do you know what we're going to do next? Yep, we're going to multiply both sides by y. So we have dy dx is 1 over x minus 4x over 1 minus x squared minus x over 1 plus x squared, all times, and then you look back up there and go, wait, what was y again? Okay, y is that mess that's way up there, right? And it looks something like this. X times 1 minus x squared over 1 plus x squared to the 1 half. Now, as I've said before, I'm a real stickler for returning things to the form that you had before. And what I had before was a fraction. All right. And so it would be nice if you combined this into a fraction, multiplied it by this, and got it back to there. But I'm going to be honest with you, for my students in my class, I'm just glad you got down to this point. Okay. But if you do get it down to one fraction, I give you extra credit. All right. Keep in mind that if you do get it down to one fraction and you're wrong, then I do take points off. All right. But the kicker here is, what does your teacher want? Okay. What does your teacher want? If they want it back down to one fraction, then you need to get a common denominator down in here and then multiply these two as best you can and then box it in. All right. But if your teacher's just like, all right, let's just do the best we can, they may be perfectly happy with this. And if you're doing this on computerized homework, I do hope it's multiple choice, okay? Because some of the computer systems that I've seen, you can type it in with just a different variation and it'll mark it wrong. So these would be hard to figure out what the computer wants as its proper form. All right. Don't forget, if you're a little bit rusty on how to separate a logarithm into the sum and difference of logarithms, there's a little support video, and that link is in the description. Please don't forget to like the video or to subscribe to the channel so that, as I understand it, the more people who do that, the more people can find it. And I will see you at the next video.